All right, fifth graders, so we are about to embark on our last new concept for your fifth grade year in math. We have built up to this point with our last group of lessons here. And in the last couple of lessons, we described or showed you how to make a net out of a 3D shape and kind of some of the reasons why we would create a net. So these last 2 or 3 lessons and quick quiz, guys, will contain this next skill, and that is finding the surface area of a 3D shape. Now, as we're looking at the page here in front of us, you can see that we have the 3D shape, and we have a net representing that 3D shape. All right, so I'm going to show you, first of all, how to use the net to find that surface area, just because that's what we're coming out of. And then in our next lesson, I will go back and use this same page, and I will talk to you about how you can still find the surface area of that 3D shape, even without creating a net, but it might make it a slightly more difficult task than creating the net from that. All right, so if we look at the first one, question number 17 up at the top, it says find a surface area. Obviously it says name it first, and we're looking at a cube there, or a very specific rectangular prism. But as you look at the net for that cube, they've got all the numbers displaced there, or at least enough numbers that we are able to figure out the surface area of that cube. All right, so as we're looking at that cube, you can see that since all the sides are the same length, we are simply going to find the area of each of those squares. Well, let's think back to finding, now this is surface area. So the formula for finding the area of a rectangle or a square is area equals base times height. We are dealing with a rectangle or a square, same thing, a specific rectangle, and that is base times height. So by creating the net, guys, we are able to see all of these faces laying down, creating them to be a 2D shape. And so we are simply going to find the area of each of these. Well, this is a height of 8 and a base of 8, so this is 64. Well, if it's 64 one time, and these are all squares with the same sides, same lengths of the sides, then all of these have to be 64. So we are dealing with a 64 here, a 64 here, 64, 64, and 64. So there are now 2 ways to find the total surface area of this cube. I can add 64 the 6 times that I see it there, or I can take 64 and I can multiply it by 6 to find that answer. Okay, now you might be looking at that net and saying, well, how did I know that the area of, let's say, this one right here is 64? Let me outline the square just so we can see it, because we don't really see 8 and 8 there. But, guys, what we know about rectangles and what we know about squares is that their opposite sides are equal. So if this side here that I've got underlined is an 8, that means this side here, I'll change colors just to give us a little bit better indication, that means this side here, even though we don't have a number on it, also has to be 8. And if this side here is an 8, that also means that this side here is an 8. So even with those ones that don't have specific numbers linked to them, and because we know they're all squares and all have equal lengths, that it's a pretty easy process to figure that one out. Now, I will say that this is one of the easier problems to try to solve, simply because once we find one area, all we have to do is count the number of faces and multiply by that number. So in this case, 64 times 6 should get us to 384. Okay, and you can again use your calculator if you are going through these types of problems. Use your calculator to try to solve them. We do allow you the use of a calculator on this unit, guys, so don't hesitate to do that. But now the label. Okay, now the interesting part of, we are dealing with a 3D shape, and this is one of the most common mistakes that people make in dealing with surface area, is because they see a 3D shape, they automatically assume that the label needs to be cubic something, or inches cube, or in this case centimeters cube, but that is not the case. Okay, the reason we lay it out as a 2-dimensional shape and why this net is so important, and the fact that we're using the term area, that brings us back to the idea of square centimeters. Any units, how many squares will cover this 2-dimensional? And we're covering the outside. This is like wrapping a present. Surface area is about how much of the outside surface is exposed. Okay? So again, I use the analogy in class, or as if we were to do a hands-on activity in class, guys, we would be taking how much wrapping paper would cover this box, those kinds of concepts. All right? Okay, so that was a cube and pretty straightforward. Now we're looking at a more general rectangular prism. Concept is going to be the same. We simply need to find the area of each of those 6 faces. We know there are 6 faces because we have, I'll make these nice and small, 1, 2, 3, 4, 5, and 6 right here. So again, just like the cube, it has 6 faces. But you will notice here, guys, that we do have some different numbers involved. So I'm going to erase my counting, just so we don't get those confused with the actual numbers we're dealing with. And the positive, guys, is as we lay this out as a net, we can see those rectangles there. We're not assuming, we're not guessing. Well, I think this one is this. We can physically see all the numbers that we need, and we can see that there are only 3 numbers being used. There's going to be a length, a width, and a height. Just like we would for the volume, there's going to be 3 numbers, but we're going to need to use them more than once. So if I'm looking at this top rectangle right here, okay, we have a height of 7 and an unknown base up on top here. We don't know what this base is, but based on what we know about rectangles already, this line here should be equal to this line here, which should be equal to this line here, which would eventually mean that the same number, 15, is the base for this rectangle. All right, so we are looking at 15 times 7. Okay, so this rectangle right here is 15 times 7, and so is its opposite side. That's another good thing about rectangular prisms, is that the opposite sides of that 3D shape, the opposite faces, are equal areas. That means we have 2 areas that are 15 times 7. All right, so now let's look at this rectangle. Let me change colors here just to give us a better idea of what we're talking about. Let's look at this blue rectangle right here. Okay, this is clearly a different size from the last rectangle that we did. We can see that it has a height of 10, but because this was 15, that means this base is also a 15. So this rectangle is going to have an area of 15 times 10, or 10 times 15, and that will be the same as this one, which is 10 times 15. So we have our 2 blue rectangles right here. 15 times 10. All right, and one last color change to get the last 2 rectangles discovered here. All right, so we are still again using the numbers 10. So here's our green rectangle right here. All right, and this one again has a height of 10, and this one has a base of 7. So this is going to be 10 times 7, and this one will also be the same. Again, opposite sides were equal. Whether this is the top, the right, whatever we determine it to be, it's going to be a 10 times 7 as well. This side is 10, this side is 7, 7 times 10. All right? So now, we don't really get to use the multiplication piece as much in this. So we could still take those areas of the 2 reds and either add them together or multiply 1 by 2. We could take the blue ones and find 1 and multiply it by 2. We could do that, or we can simply add these numbers together. Okay, so if I'm looking at this one here, I should have a 15 times 7, and I'm just going to figure this out quickly to make sure I don't mess it up. That's a 5, carry the 3. So we've got the red ones here at 105 each. So we've got 2 rectangles at 105. The blue rectangles here, this is an easy one. 15 times 10 is 150. So we've got 2 at 150. All right, and then the 2 green rectangles, another nice easy one. We're using 10, so that's easy to multiply by 10. 7 times 10 is 70. So I take those 2 70s. And like I said, guys, I could easily combine them first and then only add 3 numbers. I just like to see that I have all 6 faces here. So 1, 2, 3, 4, 5, and 6. Then I just go through my adding process. 5 plus 5 is 10, carry the 1. 7 plus 7 is 14, 19, 20, or 24, and 25. carry the 2 in that instance, kind of unique to carry a 2. And then 2, 3, 4, 5, and 6. So our surface area for this rectangular prism, guys, is 650. And again, remember that we are dealing with the 2D covering of the outside, not a three-dimensional shape, the inside, but the outside covering, so square in this case, inches, because that is our label. All right, and one last net to go through before we end this lesson and have you do an exit ticket to prove your knowledge. All right, now you can see that we are changing here, and we're also going to need to incorporate a second formula. We can't just use the formula for finding the area of a rectangle. That will work for the 3 rectangles in the middle. Base times height will work for those 3. But you can see on the outer edges as we lay this out, we have 2 triangles. And we have to remember that our area for finding, or formula for finding the area of a triangle, okay, triangle area equals base times height divided by 2, or half of base times height. All right, and remember that the height of those is the dotted line in the middle, not the angled line. We want to make sure that our height is straight up and down. So I will start, just because in my mind they are more difficult, start with our 2 triangles. The positive again is that they are on opposite sides. Those are our 2 bases. So they will be equal. And we are looking at 12 for a height and 10 for a base. So 10 times 12 is 120, but I divide that by 2 to find that area, which is 60. So I've got 2 triangles at 60. Okay, these 2 triangles are now done. The other part about this, guys, is we have to remember how many faces we have. With the first 2 problems, we had 6 faces. This time we only have 5 faces because it is a triangular prism and not a rectangular prism. So only 3 sides on the base and 3 faces going up. Now, even though it does kind of look like we have 3 equal rectangles, you will notice that we do have some different sides here. So I'm going to change to blue for the one unique one, which is this shape right here. Okay. And this is going back to our original formula now, base times height, a base of 10 and a height of 16 for 160 for our blue rectangle. And then we'll go to our red triangle for the last 2. Now these last 2 are the same, and you can see that we've got a base of 13 in both of these cases. We do still have the same height of 16. Okay, so now we've got a 16 times 13. Okay, 16 times 13. Again, go through my long division process here nice and quick. And realize that we have 208 for each of those. So this one is 208, and this one is 208. So that's where I'm getting my numbers from. 208 and 208. All right. And then I simply add them all up. Again, I'm trying to find the total, so this is an adding problem, and I have very few of these that are similar. So 8 plus 8 is 16. 6 plus 6 plus 6, I can use some multiplication there. 6 times 3 is 18, plus the 1 I have on top is 19, and end up with 2, 4, and 6. So our surface area for this triangular prism is 696, and again, covering the outside square. In this case, feet is the label. All right. So guys, I know that's only 3 examples, and this is kind of a difficult concept, but remember that we will have a lesson tomorrow on surface area, and we will have a lesson on the 3rd day for sure of surface area. So just don't be aware that this is not the only day, and if you're struggling with it, please contact me, ask some questions.